Hello, and welcome to Molecular Mania. My name is Alex, and though I might not be a sorcerer, that doesn't mean I don't know how to perform or explain some magical transformations. Today we'll be talking about phase changes, specifically about nitrogen, that is invisible as a gas, but when you cool it enough, it transforms into a liquid that you can actually see. So you can feel gas in the air, which is mainly oxygen and nitrogen. By simply waving your arms about, you can get an idea of how much there is. It's hard to feel, but that's because the air is spread out all over the place. But what if we got all of the components of the air to chill out with each other? Literally. By cooling the air to extremely low temperatures, we can actually get the air to condense into its basic forms. You may have seen this thing occurring if you've ever gone out really early in the morning and seen the dew on the grass, or even when you look up the sky and see the clouds. That is, the water in the air all around us, as a gas, condenses down back to as a liquid when it's cooled down. It goes through what we call a phase transition, going from a gas to a liquid. This principle is what creates the rain we experience as well. So essentially, all of the water molecules, once they get cold enough, begin to huddle around each other. Once that happens, they get into a form that can be seen and felt. Anyone who's belly flopped into a pool knows what I'm talking about. Water can condense at temperatures we experience in our everyday lives. Nitrogen, however, condenses at temperatures much, much cooler. For example, at negative 210 degrees Celsius or negative 346 degrees Fahrenheit. That is basically a little more than 300 times cooler than it gets in the wintertime here in Florida. It's also more than 300 degrees Fahrenheit colder than what your freezer is at home. So in order to handle such things, safety is paramount. That's why I'm going to be using these safety goggles and wearing them, and then also these cryogenic gloves. With this said, if you need something frozen now, nitrogen in its liquid form can do that. Liquid nitrogen is actually used in cooking a lot to make instant ice cream, for example. Today, though, we are going to be taking out our revenge on what we need to eat in order to get the ice cream and all of our Halloween candy. We're going to be taking our revenge out on some veggies and various fruits that I have in front of me here. Yes, I know frozen vegetables are a thing, but what if they were extremely frozen, like at the negative 346 degrees Fahrenheit? They'll actually behave more like a solid and like ice or even like a glass, and when smashed with a hammer, shatter. So they use the magic of extremely cold liquid to flash freeze these things and transform these vegetables into something like glass. Before we actually start smashing things though, and taking out our revenge on fruits and vegetables, first I want to show you guys this example, this concept of condensation that we mentioned earlier when it came to the rain and the clouds and the dew on the grass. So what I have here is a balloon full of just basically air, which is nitrogen and oxygen. And when I submerge it into this liquid nitrogen that is at those very extremely cold temperatures, we'll actually see the balloon's volume decrease in size. So why is that happening, you might wonder? Well, if we have a particular balloon full of gas, which is occupying a certain volume, once we cool it down and it condenses and all those molecules huddle next to each other like we talked about, the actual volume of the air on the inside will decrease, thus shrinking the balloon. So I'm going to now dip it into the liquid nitrogen. As we can see, the volume of the air is now really decreased. As I begin to pull this balloon out of the liquid nitrogen though, we'll actually see the inverse happen. The air that is condensed will now actually start to expand, and we'll actually get to see the balloon reinflate. So now that we're done with the science, now time for some gratuitous smashing of the vegetables and fruits. I'm getting it frozen some more yet. Now by using the sorcery of our liquid nitrogen, I've essentially transformed this pepper into glass. Now let's see what grapes can do. I may not be like my Italian ancestors Enrico Fermi before me, splitting the atom, but I will be splitting the grape. Hey, look at that. Who here likes frozen bananas? Fruit salad, anyone? Pepper's not so hot anymore, is it? I doubt the carrot will see this one coming. I hope you all enjoyed this smashing time with my fruits and vegetables and the concept of phase changes seen in nitrogen and air. Hope you all enjoy your candy and have a happy Halloween. Make sure to actually check out our other Molecular Mania videos. You'll never know what you'll learn. Have a good one.